196 under square root plus 40 under square root plus 140 under square root plus 56 under square root, then all under square root. We have to evaluate without using calculator. So let's try. So first let's solve the radicals within the square root. So 196 under square root, to solve it we can factorize it. Now at the unit place we have 6, that is an even number, and we know whenever there is an even number at the end, that number is divisible by 2. So let's start with 2. So 2 times 98 is 16, then 2 times 49 is 98, and then 7 times 7 is 49. 196 we can write it as 2 square times 7 square. Finding square root means we can take 1 from each number, so square root will be 14. So 196 under square root we can write 14. So this is a perfect square. Then plus square root of 40 will be 2 square times 10 plus square root of 140. We can factorize 140. 2 times 70 is 140. Then 2 times 35 is 70. And then 7 times 5 is 35. Or we can write here 2 square times 35 under square root plus 56 as 2 square times 40. You can factorize it and find the factors. Now when a times b is under square root, it means square root of a times square root of b. Therefore, here we will write 14 plus square root of 2 square times square root of 10 plus square root of 2 square times square root of 35 plus square root of 2 square times square root of 14 under square root. We can remove the square root with this square. So this is 14 plus 2 times square root of 10 plus 2 times square root of 35 plus 2 times square root of 14 under square root. Now you can take 2 common and write 2 parenthesis square root of 10 plus square root of 35 plus square root of 14 under square root, or 14 plus 2 parenthesis square root of 10 we can write square root of 5 times square root of 2 plus square root of 35 as square root of 5 times square root of 7, because if we write square root of 10 as 5 times 2 under square root, we can write it as square root of 5 times square root of 2 using the property a times b under square root is equal to square root of a times square root of b, plus 14 as square root of 2 times square root of 7 under square root. Now consider square root of 2 as a, square root of 5 as b, and square root of 7 as c. Then square root of 2 square, if we write, this is a square if we square both the sides, and then a square will be 2. We can remove the square root with this square. Similarly, b square will be 5 and c square will be 7, and when we add a square plus b square plus c square, it is equal to 2 plus 5 plus 7 is equal to 14, and AB is square root of 2 times square root of 5 plus BC is square root of 5 times square root of 7 plus AC is square root of 2 times square root of 7. Now if we write the algebraic expression, a square plus b square plus c square plus 2 parenthesis AB plus BC plus CA, then we can write a square plus b square plus c square as 14 plus 2 times AB as square root of 2 times square root of 5 plus BC as square root of 5 times square root of 7 plus CA as square root of 2 times square root of 7. This is the question we have under square root. Now this formula a square plus b square plus c square plus 2 parenthesis ab plus bc plus ca This is an algebraic expression, and this we can write it as a plus b plus c whole square. This, when expanded, it becomes a square plus b square plus c square plus 2ab plus 2bc plus 2ca. That means we can write square root of 2 plus square root of 5 plus square root of 7 whole square for this expression, because 14 can be expanded as square root of 2 square plus square root of 5 square plus square root of 7 square. Then it is a square plus b square plus c square, and then it is equal to 14. Then it is under square root. Now remove the square root with this square. So answer is square root of 2 plus square root of 5 plus square root of 7. How did you solve it? Let me know in the comment section. Like and subscribe. Thanks for watching.